Hi everyone, welcome back to another YouTube video. This is the third in the series of the EdgeHD setup. In today's video, I'll be focusing on acquisition software, run through a couple of concepts, show you my software of choice and how I go about setting everything up. So acquisition software is used in astronomy to control your mount and telescope accessories, to acquire astronomical data. There are a few out there. So Nina, I think, is probably one of the more common ones these days, and that's talked about a lot via several amateur astronomers. And then you have a number of sort of very well established software programs that were created many years ago and are still sort of used today. So Voyager being one of them, Sequence Generator Pro. I think my first Astro video that I watched with Trevor from Astro Backyard, he used Sequence Generator Pro back in the day. Maxim DL, another sort of very popular acquisition software program that was used predominantly with lots of people that had sort of the older DSLR cameras and sort of your S-Big cameras. SharpCap, also used for sort of live capture of astronomical data, particularly for those of us that want to sort of collimate on a live star. We'll use that. If you are capturing sort of planetary observations, then you might use SharpCap. You might equally use Fire Capture, which is a bit further down the list. There's EOS or ESO. ESO actually is more of an observatory professional acquisition software. EOS I know is an operating system from one of the DSLR sort of camera providers. And then ZWO themselves, they're very popular. They make astronomy cameras. They're now into sort of mounts, telescopes themselves, rotators, OAGs. That's off-axis guiders, and now they've produced their own acquisition software where you can control all your equipment within that software, and that's the ZWO ASI Studio, and it has a number of options from deep space to planetary to live stacking, you name it, you can find it in that software package. Okay, so who uses it? We've kind of touched on this already. So amateur astrophotographers, research professionals, observatories, universities, university labs and student projects, and casual astronomers as well, amateur astronomers. What does it typically do? So your telescope system control, it will handle that, as well as camera control, target acquisition, focusing, observation automation, as well as the data management elements. So for telescope system control, effectively if we think of the telescope as a large objective, as a large lens, effectively what we're doing is telling the telescope mount to slew to particular points in the night sky, pointing to celestial objects, syncing on those celestial objects, and then tracking throughout the observation session. Your camera control, so that will control things like your exposure lengths, the amount of gain, offset, your filters and which filters to sort of change to during the course of the night, as well as your cooling. And then some cameras have an anti-dew strip that ensures the sensor doesn't dew up during the course of your observation. Your camera control will also determine whether you want to take a single exposure, a single image, or a sequence of images. Target acquisition. So again, this kind of tells us or controls the system to center on an object within your field of view. You can perform a plate solve, so taking an exposure and then looking at the star field and determining where exactly the telescope is pointed. Auto guiding, so again, for many telescopes and mounts out there, if you want to lock in on an object and ensure you don't have star trails, you may choose to auto guide using either an off-axis guider or a dedicated guide scope. And then there are some mounts out there that are capable of long exposure astrophotography absent auto guiding. So mounts like your plane wave L mounts, mounts like astrophysics, software BISC, 10 micron ASA are all quite capable of exposures without auto guiding. And I guess some of this also depends on the focal length and the size of your setup. You'll need to make a determination as to what your mount is capable of and what help it needs to ensure you get the sharpest images that you can. Focusing, so again, during the course of the night, you might wish to set specific parameters in which you want the system to refocus and ensure, again, that you get the sharpest star field, the sharpest images. So you might do it based on specific times. So you might want to autofocus every 30 minutes if your temperature is dropping quite rapidly, every hour. You might want to do it based on a filter change. And effectively you'd be feeding this information into your acquisition software. Observation automation, so that's managing the actual sequence, when to start cooling down the camera, when to switch filters, when to dither, how to dither, and then once you've completed your acquisition software, for many people who maybe operate either semi-permanent or permanent observatories or setups, what is it that you want your equipment to do after it's completed its run? At that point, you might be fast asleep, and you might wish to park the mount in a specific location. You might wish to warm up the camera. You might wish to shut everything down. The other element is data management. So again, you've gone through a whole sequence overnight of imaging. You want all those files to be sort of saved off in a specific way, in an organized manner, such that you can access the data and manage the data accordingly. So you might want to, for example, save based on the target image that you are imaging that night. You might wish to include additional parameters like the date, the object name, the filters that you're using, etc. So my software of choice is Voyager, and we're now going to switch into the Voyager program and I'll show you what we are met with in there. Now we are in the Voyager software, and at this point I'll assume that you've downloaded all your ASCOM drives in relation to all the equipment that you're using, and effectively this is the interface that we are met with. So at the very top in this space where it says Starkeeper IT, this is our main sort of window, and it will either display things like, you know, your equipment setup if that's what you're doing, or on the fly, which I'll get into in a second, which is effectively a live view of sort of what it is that you're controlling. Down the bottom you'll have monitor, where my cursor is. And effectively this will again be a live view of specific actions that you're performing. So if you're taking an exposure, if you're doing an autofocus run, it will show all your information pertaining to where you are within the command that you've instructed the software to perform. On the far right, we have a number of commands within the command tab. So here we can see things like the mount, and it will have information as to whether you are tracking, whether you're parked, whether you want to unpark the mount. All those commands can be performed in here. You'll have your camera commands. So this is whether you want to cool the camera down. It will give you information as to what the sensor temperature of the camera is. Guiding, I won't go into that because for the purposes of this sequence, I will not be performing any guiding. RoboFire Focuser, this is the native focus application within Voyager. And it will contain information like your relative position within your focuser. The rotator, if you're using a rotator, so in this case I showed you from a focuser perspective we're using the Azato 2-inch focuser, and the rotator we're using the Arco 2-inch. Flat device, we won't go into this just yet, but we may come back to it in a later video. Observatory, as I said, if you're using a roll-off roof observatory, you may have some commands there to open and shut the roof. Likewise, if you're using a dome, you might have a bit more information there as to when to open and close the shutters, as well as whether to halt or stop the rotating rotating mechanism within the dome to either rotate or stop. We also have a status command tab there, and that will then show us the status of different elements. So for example, if you're in the middle of a sequence, it will show you where you are within your data acquisition, the current operation being performed, whether you're performing an autofocus, whether you're in the middle of a sequence, etc. That information will be displayed there. Your autofocus, again, that will show you a bit more information on the focus status. It will also have a status on your camera, your target, and when it crosses the meridian, and when it goes below the horizon, etc. And you'll also have a status of your overall sequence and when it's due to end. If you've got additional equipment such as a weather station, you'll have that information available to you there, as well as guiding and observing conditions. So if we now switch over to the top left, and I'll start with profile and work my way towards the furthest left option. So within profile, we can do a number of things here. We can either open an existing profile, we can save changes to an existing profile, we can save a profile as new, we can create a completely new profile, and we can clone a profile. So i.e. take an existing profile, cloning it, and then making a couple of changes to suit your needs. We also have a monitor. And again, depending on what you are doing, you might be in the middle of a sequence and you may wish to abort that sequence because maybe you're in a semi-permanent situation. The weather's about to turn bad and you want to abort quickly, stop your sequence run and get all your equipment safely indoors. You might want to, for example, insert an autofocus because again, conditions dictate that you wish to sort of refocus as you go along, so you'll be given the opportunity to do that within this command. You can also pause a sequence, for example. So let's say you're in the middle of an acquisition run, you notice some light clouds are rolling in and are due to subside quite quickly. You may wish to pause your sequence and let those clouds pass by and then resume when they've gone by. Section, so this is kind of what I was referring to before, and there are three main items that I personally use. So the first one is setup, and this will predominantly be the first time you set equipment up, or when you're making sort of changes to your setup, you'll use this option. So for example, if you're doing a completely new profile, you'll wish to set your camera up, your filters, and other parameters, which I will go into shortly. The next is startup. So once you've set up all your equipment, you then want to connect all your equipment and make sure it's on and functioning, and that will give you a status as to whether everything's switched on or if anything has failed, and you can turn your attention to those items specifically. And then we have on the fly. So this is now we've set the equipment up, we've connected all the equipment. This then gives us a number of options for us to either go to or insert specific coordinates within the night sky. and then we can find those coordinates. So if you know the name of the item, like the Orion Nebula, for example, designated Messier 42, you might insert M42, select fast find, and it will pre-populate the celestial coordinates for your preferred object, and then you'd go to, so that would force the mount or communicate to the mount to go to those defined celestial coordinates. You may wish to perform a plate solve, and that plate solve option is down here. Once you've done that, your solved coordinates will be inserted in here, as well as the rotation of your camera and the resolution that you achieve. And this is a derivative of your focal length as well as your sensor chip size. You also have a number of options, session options, and this is to do with, for example, setting up a sequence, running an auto flat sequence. We'll come onto that on a future video. And we have some other utility options over here. We also have a number of action buttons. So I referenced plate solving. We may wish to precisely point to specific coordinates, and this option allows us to do that. And there are a number of additional options, including sort of pointing to a target, and then rotating using your rotator, putting your camera in a specific orientation to get the field of view that you desire. We talked about a single shot. So here we can set parameters to take a single exposure, and then we can use the associated Voyager FITS viewer to view a single image. We can go to a focus star. We can talk about that in a bit more detail later on. Or we can do a precise pointing on a focus star as well. Down here we have a number of sort of autofocus options. So we can autofocus using a local field. So you can look at the star field available, and the autofocuser will take into account the star size of all stars within that field of view when determining the best focus position. Or you can autofocus on an actual position. So again, it will look at the central star within that position that the telescope is at. Or you can autofocus with Voyager's Acquire Star. So here, the telescope would slew to a star that you've defined the magnitude of, and then it will focus on that star. I guess with this said, let's now start to connect some equipment, do a semi-autofocus run, and then go. Right folks, so conscious of the length of the video, I'm going to call it the end here. Please do join me tomorrow for part 2. Thank you.